Hello viewers, you are welcome to my YouTube channel. Today's video is gonna talk about a busbar distributor box or consumer unit. In the consumer unit or distribution box, it is a place where the entire power of the building goes to every apartment or every room in that building. So in the bus bar, in the consumer unit, we have the miniature circuit breakers that are connected to the bus bar. A bus bar is a conductor made of aluminium or copper that takes the resultant current, the combined current or the total current, that is the resultant current, from the main source of the power, that is from a meter or national grid, into the consumer unit or the box. So from the box, it distributed to every room via the miniature circuit breakers. So these are the miniature circuit breakers. In this system, we have 4 miniature circuit breakers, each with their ratings, different ratings. The first one by my left is 15 amps, then 25 amps, then 20 amps, and lastly 25. That is the ratings of all the miniature circuit breakers that helps in distributing the power to every apartment in the building. So each breaker controls the power of an apartment. So in this system, it means I have 4 apartments and each breaker is in control of each of the apartment. That is the main lounge, the bedroom, the toilet, and the kitchen. So that is it. The ratings of the miniature circuit breaker depends on the power requirement of that room. That is the power requirement of the lamp holder in that room, and then the power requirement of the sockets in that room, and the fan or whatever. That is it. So I want to explain vividly how the connection is being made, and then I'll talk about the connection of a solar system or inverter with the consumer unit. If that is going to happen, it means you are combining 2 power supply in one box or in one consumer unit, meaning from the solar system and then from your national grid that comes from the meter or whichever company that sells the power to you. So in this case, this is a single phase bus bar. In this system, it is a single phase. It's a single phase bus bar because we have only one bus bar. We have only one bus bar, which is this one, and it is made of aluminium. This is the bus bar that takes the entire power from the meter to these circuit breakers and miniatures. You get it now. So this one again is the negative bus bar. So we are having two bus bars. This is a positive and the negative. That is it. But when you have two positive bus bar, meaning it is a double phase, but in this case is a single bus bar. That is a single phase. That is it. So as you can see here, this circuit breaker is removed from the bus bar, meaning there is no connection with the bus bar. So a positive current or a live current will not be in contact. A positive current from the bus bar will not be in contact with this breaker, meaning it's not going to work. You get it now. So I connect it back. If you switch off and switch on with this button, when it goes up, you are switching on. When it comes down, you are switching off, meaning you are breaking the contact with the bus bar using the switch. So what I want to talk in this video is the connection with the solar system, and then with the power of the meter. So it's going to be a closed loop. Both the solar system, which is this wire from the solar system, is coming into the consumer unit to work together with this positive wire, a bigger one, a thicker one, meaning it takes the entire current from your meter into the building to be distributed to various apartments via or through these miniatures circuit breakers. So the connection of the solar system with that of your meter or main power supply is like this. This positive wire is from the meter, this negative wire is also from the meter. Thicker wires, positive and negative. This one is from the inverter, positive one, and this negative two is from the inverter. So I am connecting this positive to one of the miniature because I am using the power supply from the main or from the meter to charge my battery. It is an inverter. It is a UPS system that used as a backup whenever the main power supply is cut or gone off. I will not use it to power my appliances as a backup. So I use it to charge my battery via the inverter, the input charger of the inverter, and also I use it in my house when there is a power supply from the external source. So this is going to be a closed loop. Everything is closed, no open circuit, a closed loop. So this is from the main, positive, negative from the main is being connected to the bus bar of the negative terminal. Then this positive is to be connected. I disconnected because I want you to understand the video. This will be connected to this positive bus bar, which takes the entire power to all the breakers here, and by extension going to different apartments or rooms in the building. Then the positive from the inverter for the charging of the inverter is connected to one of the miniature, meaning you get it. I'm getting power from the miniature to charge my inverter. But when there is no national grid or no power from the external source, I want to use my inverter or the UPS to power my appliances. That is why there is another positive wire that is coming from the AC output of the inverter, and then this is it. I connected it with the positives that distribute the power to the rooms in my building, and they are being disconnected from the miniatures, and that's why this miniature has no positive wire. This one too has no positive wire, but this one is for the kitchen. I didn't use it. The kitchen isn't connected with the inverter, so the kitchen used the national grid or the power from the meter. These two that are connected with the AC output of the inverter were removed from this one and this one, meaning I have the supply of the inverter to these two positive wire that are connected with the positive of the AC output from the inverter. So it's going to be a closed loop. In this system, the changeover will be automatic. It is an automatic changeover. You don't need a manual one. It changes automatically. When there's power from the meter, it enters automatically. When there's no power from the meter, you continue enjoying your power from the inverter or the UPS automatically. Thank you very much. Thank you for watching my video. Thank you for subscribing. Thank you for liking it. Watch out for more content, more videos on how to. Thank you very much.